Imagine this. On a frigid March morning in 1926, a solitary inventor stands in a Massachusetts cabbage field, igniting a contraption that rises just 41 feet into the air. That humble hop. It was the world's first liquid-fueled rocket, and the birth of humanity's leap to the stars. Robert Goddard, the forgotten father of modern rocketry, turned science fiction into reality, all while the world laughed. Today, we dig into Goddard's quiet fire that still burns bright in our skies. To understand Goddard's spark, step back to the dawn of the 20th century, a time when America was shaking off the shadows of the Gilded Age and charging into an era of boundless invention. It was 1882 when Robert Hutchings Goddard entered the world in Worcester, Massachusetts, a bustling mill town humming with the clatter of textile machines and the promise of progress. The air buzzed with possibility. Thomas Edison's electric lights flickered on in homes, Alexander Graham Bell's telephone connected distant voices, and the Wright brothers' 1903 flight at Kitty Hawk proved humans could conquer the air. But beneath the optimism lurked tensions. The progressive era pushed for reforms amid labor strikes and urban sprawl, while World War I loomed on the horizon, demanding innovations in weaponry and flight. Society idolized bold aviators like Charles Lindbergh, yet dismissed dreamers who gazed beyond the atmosphere. Science fiction stirred imaginations. H.G. Wells' The War of the Worlds painted Mars as a tantalizing frontier, but rocketry. That was the stuff of fairy tales, powered by gunpowder toys from ancient China, not serious engineering. Into this whirlwind, young Goddard climbed a cherry tree on his 17th birthday in 1899, pondering how to reach other worlds. Tuberculosis sidelined him for months, but it fueled his resolve. By 1911, with a PhD from Clark University in hand, he joined the faculty there, teaching physics while tinkering in secret. America was on the cusp of global power, yet Goddard's vision, to propel humanity beyond Earth, seemed impossibly distant. Little did the world know, one man's persistence would rewrite the stars. Robert Goddard's life was a masterclass in quiet determination, a tale of a bespectacled professor, more at home with blueprints than crowds. Born to a machinist father and a bookish mother, he grew up dismantling clocks and dreaming big, his fragile health no match for his curiosity. By his teens, inspired by Jules Verne's lunar voyages, he sketched rockets in notebooks, calculating trajectories under Worcester's starry skies. But Goddard wasn't one for fanfare. He worked in shadows, driven by a belief that the impossible was merely untested. His first pivotal breakthrough came in 1914, when he patented a solid-fuel rocket design, simple tubes of gunpowder that could loft cameras to scout weather patterns. Yet Goddard dreamed bigger, liquid fuels for controlled power. This led to his landmark 1919 treatise, A Method of Reaching Extreme Altitudes, published by the Smithsonian Institution. In a letter proposing the work on September 27, 1916, from his Clark University lab, Goddard wrote to the Smithsonian's president, "Seeking funding after years of solo experiments. For a number of years I have been at work upon a method of raising recording apparatus to altitudes exceeding the limit for sounding balloons. And during the last 2 years I have tried out the essential features of the method at the laboratory of Clark University with very gratifying results. These experiments are now completed, and I feel that I have settled every point upon which there could be reasonable doubt." The purpose? To secure support for scaling his ideas from balloon heights to stratospheric realms, proving multi-stage rockets could carry scientific instruments or even messages to the edge of space. This 69-page paper laid the mathematical groundwork for escape velocity, influencing generations and earning him Guggenheim funding in 1929. Its impact? It transformed rocketry from hobby to science, directly feeding into NASA's equations for orbital flight. But words on paper weren't enough. On January 14, 1920, during a rare interview with a Boston Herald reporter at Clark University, Goddard handed over a copy of his treatise, saying, "That tells the whole story." The setting was tense. Press curiosity swirled after leaks about his moonshot ambitions. His purpose, to deflect sensationalism and point to hard data, underscoring his methodical approach amid growing ridicule. Tragically, This sparked a New York Times editorial mocking him. Professor Goddard fails to concentrate on the obvious fact that no rocket can propel itself in a vacuum. Goddard's response in the same interview? In self-defense, I have to fight shy of the newspaper men. This quip revealed his vulnerability, a brilliant mind guarding secrets from a skeptical world, yet it fueled his resolve, preventing distractions as he refined designs in secrecy. That wariness preserved his patents, which later armed Allied forces in World War II. The pinnacle arrived on March 16, 1926, in a snow-dusted field near Auburn, Massachusetts. With his wife Esther as photographer and assistant, Goddard lit the fuse on his 10-foot, 11-pound rocket, fueled by liquid gasoline and oxygen. It sputtered, then soared 41 feet for 2.5 seconds before crashing. Understatement defined him. In his diary entry that evening, he noted, "It is a day to be remembered forever." Written in his private Worcester notebook amid the chill of failure's edge, the purpose was personal reflection, to mark a milestone in liquid propulsion, the holy grail for sustained thrust. This launch's impact? It validated liquid fuels as viable, birthing the tech behind every Saturn V engine, turning Goddard's garage tinkering into the blueprint for space travel. Goddard's innovations didn't stop there. Over 200 patents followed, including gyroscopic steering in 1932 for stable flight, tested in New Mexico's deserts, far from prying eyes, and variable thrust pumps by 1936, precursors to modern engines. Funded by the Guggenheim Foundation after 1920 struggles, he collaborated with the U.S. Navy on bazookas during World War II, adapting rockets for anti-aircraft defense. In a 1938 notebook entry, reflecting on critics during isolated Roswell tests, Goddard penned, "It is difficult to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow." The setting, his desert workshop, purpose, to steel himself against doubt as geopolitical tensions rose. This mantra encapsulated his philosophy, inspiring engineers like Wernher von Braun and embedding resilience in American innovation. Finally, in an unpublished 1941 speech draft for the American Rocket Society, he urged, "Every vision is a joke until the first man accomplishes it. Once realized, it becomes commonplace." Penned amid wartime secrecy in Annapolis, Maryland for the Navy, its purpose was to rally peers toward practical applications, like guided missiles that helped win the war. These words ignited a field, proving visionaries like Goddard turned jests into legacies. Goddard's ripples reshaped American history from the ashes of World War II to the Apollo triumphs. His liquid fuel breakthrough and patents directly informed the V-2 rockets captured post-war, which von Braun refined for NASA's Mercury program. Without Goddard's math in that 1919 paper, the 1969 moon landing, watching Neil Armstrong's one small step, might have stayed fiction. His bazooka designs saved countless lives in Europe, while his secrecy ethos protected intellectual property, fueling the U.S. military-industrial complex that won the Cold War space race. Today, in 2025, Goddard's shadow looms large over our tech-driven world. As private firms like SpaceX slash launch costs with reusable rockets, echoing his multi-stage genius, we're witnessing a commercial space boom valued at $500 billion, directly tying to education in STEM, where Goddard's underdog story inspires underrepresented youth to pursue engineering amid America's push for innovation equity. Yet his legacy warns us, in an era of AI ethics debates and geopolitical space rivalries with China's lunar ambitions, Goddard's call to settle every point upon which there could be reasonable doubt urges rigorous, unbiased science. His work underpins the Artemis program's return to the moon, addressing contemporary issues like sustainable resource mining for climate tech, harvesting helium-3 to power clean fusion energy, combating environmental crises. Goddard's treasures remind us, bold evidence-based invention isn't just history, it's our safeguard against tomorrow's unknowns. Robert Goddard, the tree-climbing dreamer who dodged headlines to chase horizons, unearthed rocketry's potential when the world saw only folly. His patents, launches, and unyielding quotes, from cabbage fields to classified labs, propelled America from terrestrial tinkerer to cosmic pioneer, proving one persistent mind can redefine possibility. In an age of rapid tech leaps, Goddard's awe-inspiring path calls us to nurture hidden geniuses, turning doubts into destinations. What hidden treasure of American history should we unearth next? Drop your ideas in the comments below. We read every one. If this sparked your curiosity, hit subscribe and that bell for more episodes. Like the forgotten fossil hunter who challenged Darwin. Your support keeps these stories alive. Thanks for joining the dig. Until next time, keep looking up.